Today's notes are going to be on factoring. We're going to focus on pulling out a greatest common factor and factoring polynomials when the a value is equal to 1. So first, to start, we have some vocabulary terms to look at. The first is for a monomial, which is a polynomial with one term. So an example would be 32 or 4x. For a binomial, you have two terms. So an example would be 9x minus 4. So 9x is one term, 4 is the other. Or another example would be x cubed plus 7. A trinomial is three terms. An example would be 4x squared plus 3x minus 9. When we factor, we will be rewriting an expression as a product of values. In each term, we are going to look for a common factor. This common factor is factored out in front of the other leftover terms. So we are undoing the distributive property. Let's look at factoring example number 1. The first thing I want to look for is what factor each term has in common, and if you can't identify it right away, you can always list each term as a combination of its factors. So 5x cubed can be written out as 5 times x times x times x. Negative 10 can be written out as negative 2 times 5 times x times x. And negative 25 can be written as 5 times 5 times x. Now I'm trying to look at which factors appear in all three of these terms. So they all have a 5 and they all have an x. That's your greatest common factor. It's going to sit out front, and inside the parentheses are going to be your remaining terms. So the first term has an x squared left, the second term has a negative 2x left over, and the third term has a negative 5. This would be your final factored expression. Please try to factor example number 2 on your own. Next, we're going to look at example number 3. In this case, the greatest common factor that appears in all three terms is a quantity, and it is the quantity y plus 1. So the quantity y plus 1 is going to sit out front, and the second set of parentheses is going to be all of the factors left over. So the first term still has a 2x squared, the second term still has an x, and the third term has a negative 4 still. So all I did was take this y plus 1 and put it out front. This would be your final factored polynomial. Please use example 3 to help you try example 4 on your own. For factoring a polynomial when a equals 1, a being the value in front of the x squared, your first step is going to be to factor out the greatest common factor like we did on the last page. Then you're going to set up the answer in the form of the quantity of x plus m and x plus n, where m and n will be replaced with numbers. To find m and n, we are going to look at the c and b values of our polynomial. We are going to make a list of factors of c and then see which pair of factors adds up to b. That pair will be plugged in for m and n. So looking at example 1, the first thing I'm looking for is to see if there's a greatest common factor. In this case there's not, so I can go to setting up my problem. So I'm going to have x plus some number, and then the quantity of x plus some other number. In order to find what's going to get plugged in, I want to make a list of factors of negative 28, and to start I'm going to ignore the negative. So I have 1 and 28, 2 and 14, and 4 and 7. If you have trouble making the list of factors, use your calculator to help you. Try 28 divided by 1, 28 divided by 2, divided by 3, divided by 4, and so on. We're looking for whole numbers to be included in our factor list. Now that I have my full list of factors, I want to decide which pair adds to my b value, which is negative 12. So keeping in mind that because I'm multiplying to a negative number, one of my factor pairs is going to be negative, I can use a combination of 2 and 14. So I'll be using a positive 2 and a negative 14. Together they multiply to negative 28 and add to negative 12. So my answer is x plus 2, and then because it's negative 14, this is going to become x minus 14. It does not matter what order you list the factors. So that is my answer for example number 1. Next, let's take a look at example number 2. First thing I need to do in example number 2 is notice that there's a greatest common factor. In each term, I can pull out a 3x. So if I pull out the 3x, I'm left with x squared minus 8x plus 12. When I set up my answer bracket, the 3x is going to hang out front, and then I'll set up my two quantities for my x plus my factors. When I'm identifying the factors of c, your c value is after you pull out the greatest common factor, so I'm trying to figure out what numbers multiply to 12. So I can use 1 and 12, 2 and 6, and 3 and 4. Then, from this list, I'm trying to determine which adds to my b value, which again comes after you pull out the greatest common factor. So I'm looking to see which one adds to negative 8. I'm going to be using the second pair of factors, and both numbers are going to be negative. They multiply to a positive 12 and add to a negative 8. So my answer is 3x times x minus 2 times the quantity x minus 6. We're going to do the same thing again here as we look at example number 3. First thing I'm going to do is pull out a greatest common factor, which for this example is a negative 2xy. I'm going to pull out a negative so that my a term is a positive 1. This will leave me with x squared plus 2x minus 48. So I'm going to leave my greatest common factor out front as I set up my answer brackets. My c value is now negative 48. So numbers that add to 48 would be 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Next, I need to decide which adds to my b value, which is a positive 2. So my only combination I can use down here is with the 6 and the 8. And for this to work, it's going to be a negative 6 and a positive 8. So negative 6 times 8 gives me the negative 48 I was looking for. Negative 6 plus 8 gives me my positive 2. So my answer is negative 2xy times x minus 6 and x plus 8. Again, you can write these factors in any order as long as you keep the greatest common factor out front. 4 is going to be a little bit different because I have x and y that'll be left over when I'm factoring, because the greatest common factor is 2x. So after I pull out the 2x, I'm still left with x to the 4th power minus 8x squared y plus 12y squared. So not only do we have an x to the 4th power, we also have that y squared at the end. So when you're setting up the problem, your 2x is still out front, but instead of having x plus a number, I'm going to have x squared plus some number times y. The second part works the same. I'm still looking for factors of my c value, which are 12, so I can use the same list of factors as example number 2. And again, I'm trying to find which ones add to negative 8. So I'm going to be using the second factors again with negative 2 and negative 6. So we're using the same factors as example number 2. And I'm going to fill this in here to give me x squared minus 2y and x squared minus 6y. If you want to check if you do any of these correct, you can FOIL your two binomials together, so first, outer, inner, last, and then distribute the 2x to everything and combine like terms. If you factored correctly, you should get back to your original answer. Please try the 3 examples on the next page on your own, and we will talk about them tomorrow in class.